As Comet K2 makes its way deeper into the inner solar system, the big question that astronomers are asking is, what's next? What will happen to this massive icy object as it draws nearer to the Sun? Will it continue to glow brilliantly, offering skywatchers a rare and beautiful sight? Or will it fragment, disintegrate, or even completely vanish, like so many other comets before it? The truth is, comets are notoriously unpredictable. Their behavior can change drastically, sometimes without warning. As they approach the Sun, increasing solar radiation can either fuel them into spectacular displays or tear them apart. The balance between these two outcomes is delicate, and we're not yet sure where K2 stands. According to the current trajectory and velocity calculations, Comet K2 will reach its perihelion, its closest point to the Sun, on December 19, 2022. At that moment, it will be about 1.8 astronomical units, AU, from the Sun. That's roughly 270 million kilometers, still much farther than the Earth's own distance from the Sun. That's a key point. K2 is not expected to get close enough to the Sun to produce the kind of super bright display that other sun-grazer comets have in the past. But that doesn't mean it won't still be worth watching. From now through the end of 2022, the comet will remain visible with small to medium telescopes, particularly in the southern hemisphere after mid-September. As Earth's position changes relative to K2's path, our perspective improves, and observers from countries like Australia, Chile, South Africa, and Argentina will get the best views. This southern visibility window gives us a continued opportunity to study the comet in detail, especially with professional observatories. Astronomers will be monitoring its activity level, tail evolution, and coma structure, looking for signs of fragmentation or fading. Infrared telescopes, spectrometers, and even amateur astronomers will all play a role in this effort. But what if K2 breaks apart? It wouldn't be the first comet to do so. In fact, many comets don't survive their first close encounter with the Sun. The heat and gravitational forces can crack them, especially if their structure is weak or porous. In some cases, we've even witnessed comets split into multiple pieces, like Comet Ison in 2013 or Comet Shoemaker-Levy 9, which famously broke up before colliding with Jupiter. However, K2 has shown surprising resilience so far. The fact that it's already been active for years and has maintained a stable coma and tail suggests a certain structural strength. It's also approaching the Sun at a safer distance than many previous comets, which reduces the likelihood of total disintegration. That said, until it completes its perihelion, we can't be entirely certain. Another possibility? K2 could go dormant. As the comet rounds the Sun and begins to head back toward the outer solar system, its source of heat will fade. The outgassing will slow, the coma will dissipate, and the tail will vanish, leaving only a frozen, silent object drifting once more into the dark. Whatever the outcome, one thing is sure. We're watching a cosmic drama unfold in real time. From its ancient origins in the Oort cloud to its long journey through the void, Comet K2 is a time capsule of the early solar system, telling us stories written in dust and ice. At Infinity Beyond, we encourage you to keep your telescopes pointed skyward and your curiosity alive. In the next and final segment, we'll reflect on what Comet K2 teaches us about the formation of our solar system and why events like this ignite wonder in the hearts of people across the planet.